All right, so we are off to our first customer presentation. I have Tom, who's coming up from Vodafone. As I mentioned earlier, he's going to be talking about how they're using the Validated Patterns Operator and GitOps to simplify their lifecycle management. Thank you, Tom.
Thank you. Right, welcome everybody. I'm Tom Kivlin. I'm from Vodafone. I'm Principal Cloud Architect. And today we'll be discussing a few things. So I'm going to start by outlining the challenges we've had in managing the lifecycle of Kubernetes clusters in the past. I'll do a brief overview of validated patterns and GitOps and what they are and how we've used them. Then how we've implemented validated patterns operator and our pattern at Vodafone within our network, the benefits we've seen from that, and then hopefully I'll have some time for some Q&A at the end. So challenges, I'm sure many of these are common across the room and not unique to Vodafone. So starting on the left, one of the key things we've seen with the adoption of containers and Kubernetes within our network is that we need to adopt a faster pace of lifecycle operations. So the area of the business I work in is within the 5G Telco cloud. Part of the point of making that containerized was so we could release new features, develop new capabilities, release software more rapidly at a higher cadence. And so that requires the ability to upgrade more regularly. That aligns with the overall Kubernetes approach of 3 releases a year, support for a year, etc., which coming from a traditional telco background is a lot faster than we're used to. Now, coupling that with complex dependencies between the applications that we run, so the 5G software and the platform itself, and it can be that configurations being managed through spreadsheets or other mechanisms introducing consistencies. And then adding to that, if you are managing the lifecycle of these clusters manually, that can introduce human error. That leads to incidents, and I don't necessarily mean production incidents, but problems that need fixing in pre-production as you're doing lifecycle operation testing and validation. And all of this together means deployments, upgrades, they take too long, they're too complicated, they're high risk. So this is a slide from Red Hat to explain what validated patterns are. Now, the purpose of them is to simplify how we manage lifecycle of the platform as a whole, not just the OpenShift clusters. So the concept is, think of it as a kind of reference blueprint as code. So taking the infrastructure as code, configuration as code concept, building it, so that in effect a validated pattern is a collection of operator subscriptions, Helm charts, secrets, other artifacts that are packaged up and ready for you to either use or adapt to your needs. So I'll show you in a minute how we've adapted a couple. And the idea is, as I say, you can take these things. They've been some of them have been validated by Red Hat, some of them have been validated by partners. And they're based on various use cases. So some are based on multi-cluster GitOps, some are talking about DevSecOps, some are specific to the medical industry, and so on. Excuse me. And as it says on the screen there, so they're highly reproducible. So one of the challenges we've had in the past is how that configuration is managed. Just applying the configuration as code concept to literally everything about the platform means it's consistent. You repeat it, do it once, twice, 3, 4, 10 times, it's the same result every time. So how have we implemented it at Vodafone Networks? So we've started from 2 main patterns that are maintained upstream. So one is the multi-cloud GitOps pattern. The other is the DevSecOps pattern. And we've worked with Red Hat Consulting to, as I say, adapt those patterns, adding in our own Helm charts, our own artifacts to produce a pattern that's useful for us to deploy a hub cluster, so the management cluster, all the management capabilities, which is then ready, straight away ready to use the advanced cluster management tool and zero-touch provisioning artifacts to then build and manage many workload clusters. So they're running CNFs, which are cloud-native network functions. So they're the applications actually providing the 5G functionality. So all of this is, as I say, adapting what's already in place, taking those upstream patterns, storing them in Git, and then using Git version control, branch protection policies, approval paths, to then trigger the automation of that configuration through a GitOps controller, which is Red Hat GitOps using Argo CD. So what is our pattern? What does it look like? So today we have a number of operators. And as I said earlier, a pattern is a collection of operators and Helm charts. So the operators, you may be familiar with some of the things on the screen. We've got ACM, we've got Advanced Container Security, so the ACS product, Data Foundation for the storage within the hub cluster, Red Hat Key, which is the container registry, to store the images required. So we often run disconnected environments, so the hub cluster doesn't have access to the internet, so we need to be able to mirror the images locally. Keycloak is our authentication provider within the data center for this platform. So all of the workload cluster, APIs, consoles, and so on, and many of the applications in the hub cluster will integrate with Keycloak either directly or via the OAuth server within OpenShift. And so that provides us with a single sign-on mechanism. Then we've got Ansible Automation Platform, which we use to manage the life cycle of the Ceph storage clusters that we have within the environment. So whilst we use internal data foundation within the hub cluster, within this environment that I'm sharing with you today, we use external ODF with a Ceph storage cluster for the workloads. And so that's lifecycle is all managed by Ansible. And then we've got, as part of ACM, we've got the observability suite. So all of the metrics, alerts, the logs that are produced by the workload clusters and the platform components within the workload clusters, they're all forwarded to the hub cluster centralized, so operations have a single point of, a single view of, everything they need to understand the state and health of the environment. And that's the same for Ceph as well. So all of the Ceph, Prometheus, and Vector components forward those metrics and logs to the hub cluster. And then further integrations occur from the hub cluster using Alert Manager and Loki Stack. And there are more. So I mentioned we've got some custom Helm charts. So that's for things like we've got our own custom certificates that we use our own root CA to sign. So that's added into the pattern as something that's applied. We've got our own backup and restore needs. So all of the OADP configuration and the destinations and the schedules and so on, that's all a Helm chart that's specific to us, but it's part of the pattern. And so there's a bunch of those. We've probably got, as well as the ones listed on here, another 6 or 10 maybe, of kind of custom Helm charts that are, that we maintain and develop ourselves. So what have we learned by doing this? So as I alluded to earlier, one of the benefits of the configuration as code concept that this enables is the reliability. So moving from kind of configuration in spreadsheets, manual entry through GUIs or, JSON files or whatever it might be, we're now using, more easily human readable configuration, which is then version controlled in Git and then automated through Argo CD. So we find we can rerun it dozens and dozens of times, and we get the same result every time. Now, it reduces human error, it doesn't eliminate it, so it's still possible to put the wrong value or a quote mark in the wrong place in a YAML file, and it will still produce a problem. But the likelihood of it happening has gone down because you're reviewing using Git review techniques and so on. So it doesn't remove it completely, but it vastly reduces it. And that, in turn, has increased our agility. So I mentioned the validate patterns operators provided the springboard. It's not the entire solution. So I mentioned earlier we use the zero-touch provisioning artifacts with ACM. Now I think they were developed for the RAN, so radio part of the telco industry. But they're very useful because any of you who have developed ACM policies, it can be quite complex to manage them yourself. It's kind of embedded YAML and so on. Whereas the zero-touch provisioning artifacts, the policy gen templates specifically, is a custom resource that Red Hat have developed and released and made available that make you simply refer to YAML files that are native normal YAML files with Kubernetes resources in them. And so you refer to those and it builds the policies for you, which when you're managing lots of clusters at scale in lots of different environments is going to be a huge benefit in terms of managing what policies need to be in place. And then I mentioned as well, so Git with the version control and approvals for execution, we can use the standard mechanisms. So we use GitHub, so things like branch protection rules, code owner files, etc., to make sure the right people are having to review any changes, the right people can approve changes, and that then triggers any automation of the configuration to be applied. So the third column is the kind of, I'm not going to say negative things because they're not negative, but the things that are difficult about what we've done. So one thing is it's very different. People are used to using GUIs, they're used to using spreadsheets, and moving from that to managing everything in YAML with Git and Argo CD pipelines has been a challenge, and it's a steep learning curve for everybody, engineering teams, operations teams, architects, and so the consulting team with Red Hat have been very useful and helpful in helping us to achieve that. But it has also brought benefits in being able to people to understand the kind of the life cycle of a change and see it happen and be in more control about how it's happening. The second point there is I mentioned we've got in the pattern I showed earlier, we've got many standard Red Hat components, ACM, ACS, Ansible, Key, etc. Not all of those fully track upstream Helm charts. So for example, I'll just pop back to there. So take ACM as an example. So that's a combination of an operator subscription and a Helm chart to deploy the component within the hub cluster. Now the Helm chart is custom for Vodafone because we are integrating it with our backup system. And so we've modified the Helm chart that's provided as part of the multi-cluster GitOps pattern that's validated. The operator subscription is the same, but the Helm chart is specific to us. So at some point we need to work out how do we link better to these upstream Helm charts? How do we track differences so when developments happen upstream, we incorporate them into our pattern, into our Helm charts, and so on? Now, the idea is that over time, some of these things, I think one of them for Ansible, it's actually something we needed, wasn't available, but we'll work with the Red Hat team to get that into the upstream Helm chart, and then we'll adopt that. But that's a challenge that we're working through. And then the final bit is more of a question, is whether we need a telco pattern. So there are industry-specific patterns. I mentioned there's one for medical, there's others. Red Hat have telco reference architectures and reference design specifications. And so it's a question we're discussing with Red Hat and others in the industry. Should we make those reference things a telco pattern, or are we all in telco so different that actually my pattern at Vodafone is going to be so different from EE's pattern or Orange or whoever else might be using OpenShift? I don't know. So those are the lessons that we've learned at Vodafone. There's a slide here. I assume the slides will be made available to the audience. These links will have some really useful information. And I want to call out especially, there's a validated pattern special interest group as part of OpenShift Commons. The web page there takes you to a page with loads of articles and videos, blog posts and content, which is really useful if you want to find out more about validated patterns in particular. So, we're a bit early, but thank you. Open the floor up to any questions.
Hello, my name is Roman Labera. I'm from O2, Czech Republic. I'd like to ask you, how do you manage the life cycle together with the verification or certification with the CNF supplier, together with the pace of the Kubernetes life cycle, because there is every 4 months, or do you follow 8 months life cycle management or updates? And second question is regarding the CNF workload cluster. If you have, could please give us some reasons why did you separate CNFs by clusters? Is it because of life cycle or vendor management or technical or different reasons?
So I'll answer the second one first because it's fairly quick. So there's various reasons, and it differs in different countries where we'll be using this. So the kind of hard separation at the moment is vendors. So we have various telco vendors, Nokia, Ericsson, Huawei, Samsung, etc. And at the moment, we don't share clusters, with multiple vendors running in them. That's just it's an us decision. Apart from that, there'll be other reasons. So it might be that certain CNFs require, net raw Linux capability or something, and actually fine because you need to do some high throughput networking, but we don't necessarily then want CNFs that are handling sensitive data to be running in that same cluster because there's the risk of exposure and so on. So there's various reasons that will go into why CNFs are separated, but it's not that every CNF has its own cluster. So apologies if that's how it came across. That's not the case. We do have multiple CNFs in a cluster. To answer your first question, so we try and will continue to try to stick to the EUS releases of OpenShift. So the even minor numbers, which is every other Kubernetes release. So at the very fastest, we'll be upgrading OpenShift every 8 months, but we do it in conjunction with the CNF vendors. So we don't kind of mandate you have to do it every 8 months or you have to do it every 12 months or whatever. But because different CNF vendors kind of have their own cadence for the CNFs and the capabilities they're delivering. So it's a kind of collaboration at that level.
Are there any problems with vendors of CNFs to keep this paced?
So
maybe Nokia is not, I know that we have some problems with Nokia to keep the updates and verification on time before the LTS version is...
Yeah, there's different vendors have different approaches. So some are very quick in supporting a new version. Some are a bit slower, and we need to balance that spectrum. So
Thank you very much.
Okay.
Hello, hi, Jonathan. I see, I'm not sure you mentioned, but are you using HyperShift for the CNF deployment, or that's full cluster deployment?
HyperShift is hosted control plane, is that right?
Yeah.
Yeah, no, not yet. So HyperShift hosted control plane is GA in 4.18, I understand, but it's not yet fully supported for telco use cases. Now, I can't remember the exact reason, and Red Hat people may tell me off, but I think it's something to do with the TuneD operator and the performance profiles that we need to run for certain telco workloads. That isn't yet supported using hosted control planes. But our intention is to use that once we can, but it's not yet available to us.
Particularly because OVN, it's a virtualization layer. Maybe it's not a good one. Yeah.
Yeah, I don't know, I haven't been into the technical reasons, but yes, our intention is absolutely to move to that, to make the control plane of those workload clusters more efficient in terms of hardware use.
And in that case, all the CNF, you have it a free node deployment. It could be a big cluster deployment. It's really, you have really a different set of deployment today? Or?
Yeah, it varies. So some CNF clusters are small and the control plane will be schedulable. Some are, dozens of nodes with, all full, So it varies in terms of scale.
All right. How many of you are currently OpenShift GitOps or Argo CD operator users? Okay, so there's a fair number of hands up in the room. I know you mentioned that it's not the most easiest tool to use, it sounds like. Is that a similar experience for everybody in here? No, yes, I'm seeing both, so.
So the bit that we find less easy was ACM. So the GitOps part, so Argo CD is dead simple. It's very native to Kubernetes and OpenShift. ACM, as well as managing the lifecycle of multiple clusters, allows you to apply policies to apply to all of those clusters. And the way those policies are you can either use the ZTP policy gen template, which is easy, or you can manipulate the policy manifest yourself, which is a bit trickier, and we found prone to error.
Got it, okay, thank you. Any other questions in the room while we have the time? And is August Simonelli in the room by chance? I know there were some updates with ACM and GitOps, so I will try and find him and push him your way later too, because I think there's a little bit of a push to make that slightly easier going forward. Okay, thank you so much, Tom. Appreciate you being here.
Thank you.